All right, hello everyone, and welcome to this next session. So it's almost 4 p.m. and I'll get started very soon. So just before we start, I just wanted to ask if anyone has any doubts about the previous sessions. So I guess there are no doubts, and since it's 4 p.m., I will get started. So as I said in the previous session, in this session, we will get started with Pandas. So just a little bit of history. If you look at Pandas, Pandas is one of the main, what do you call, the base for almost all data science related with Python, right? So in simple terms, you can say that Python Pandas is the equivalent of Excel sheets for data science. So for example, when we actually look at how you want to analyze data, in simple terms, what we just use an Excel sheet. So an Excel sheet, we have rows and columns, we have data within that. We sometimes have our own calculations. We can even generate little plots with Excel and all those things. Now, you could use Excel, and for many applications, Excel is good enough, right? So typically, if you have, let's say, just around 10,000 rows of data, Excel is good enough. Now, beyond that, that is when Excel becomes a little bit of a pain. Also, if you want to do something a little more complicated, Excel can be a little tough to use. This is when Pandas comes into play. So you can install Pandas. You can just check out this documentation page. You can install Pandas. You can do a lot of things. So in this lecture, we'll get started with that. So let me just create some space. The first thing you need to do is you must import Pandas. Now, just like we did with NumPy, import Pandas is all you need, right? But in most data science projects, you'll see the convention is to import Pandas as PD. And usually, when you import Pandas, it is also customary to install NumPy as well. So let's do these two imports together. So before I actually start talking a little bit about theory, I'll just start creating some Pandas data frames and we'll talk about it soon. So there are two types of data with Pandas. Actually, there are several types of data, but the two major types of data. The first is a series, and the second is a data frame. So we'll talk about both of them. So the first thing you need to do is let's call a series. So let's call this series 1. What is a series? To be able to use a series, we use this method. So series is a function call, or rather it is a constructor of an object which is available with Pandas, right? As before, PD is the object, PD is the package. Within the package, it has several objects. And one of these objects is series. So series is a complete data type on its own, right? So let's look at the help and see what it is. So you see, this is the main structure of a series. You have data, we have index, you can specify the type if you want, but it'll automatically take it. You can give it a name, and if you want, you can say whether this is a copy or not, right? So most important are data and index. So let's work with that. So the first thing you need to ask is, what kind of data can you expect with this? So let's comment this for now, or rather just cut, copy, paste it here. Now, first is let's create a data type. So let's say I have something called NumPy, and let me create an array. Let me create an array of 5. Okay. So X is basically 0, 1, 2, 3, 4. Okay. Now, the question is, if I want to push this NumPy array into this series, How will I do so? The simplest way to do it is just to take this function call, that is pd.series. This is called a constructor, but never mind. This is how you create a series object and just specify x, right? Now, remember, if you do not specify anything, this is taking the arguments by position. So the first argument is data. So x is the data. So if you want to be explicit, we can specify this data is equal to x. Let's just run this and see what we get. This is our series. All right. So now I'll just stop for a minute and ask, does anyone have any doubts so far?
So what exactly is happening here? It's converting it to a matrix or what?
That's all right. So now first thing is series is a separate data type. So for example, let's say we say type series 1. You see, it is a separate data type. This is not an array. This is not a list. This is a separate object completely, right? It's a series object. Now, how do you decipher this? Let's say, for example, let me create another one. Let me take this because both of them are the same. It's a little confusing. Let me say multiplied by 2. Series 1. So now you see, now it's fairly clear. What do you see? On the right hand side are the values, right? These are the actual values, 0 to 4, 8. This is the value x into 2. This is the data that we are passing in. On the left is the index, right? So again, for this, just go back to this and see what we're getting. The first one is data. The second one is index. We have not specified an index. When you do not specify an index, Pandas will automatically create an index, and that index is typically just integers from 0 to whichever number is there. All right. So let me find out what this is. If you, again, like it's an object, right? And like with all objects, you can do tab and find out all the methods that are available with this. All right. There are many. Here, there is something called index. And you see the index is a range index starting from 0 to 5. So basically, this is a list. You can just cast it as a list because it's a range. And you see, this is what we get, 0, 1, 2, 3, 4. This is an automatic index which is generated by Pandas. All right. So here again, I'll stop for a minute. Does anyone have any doubt? This is a complicated topic sometimes to begin with. So I would encourage you to ask as many doubts as possible.
Yes, Kumar, I missed that initial part when we first declared series 1, right? And we obtained two columns, two same columns, right? 0, 1, 2, 3, 4,
yeah,
and 0, 1, 2, 3, 4. And I missed that part. Why it is so?
No, that is it. So basically, it's just like this. As I said, the way you create a series is these are your arguments, right? These are all the arguments. And you see the values here. These are the default values. So the first value is data. The second value is index, right? Now, if you pass a data, but you don't pass an index, Pandas will create a default index for you. And that default index is basically integers starting from 0 to whatever, just like in Excel. In Excel, the rows are numbered from 1 onwards, 1, 2, 3, 4 onwards. In the same way, in Pandas, it will create a default index starting from 0 and continue as integers, right? So here we did not specify index. We specified a data. And that data was basically 0, 1, 2, 3, 4. So it gave us a column of data objects. On the right-hand column is the data. The left is the index. Now, this was the first example. I created this example to differentiate between the data and the index.
Yeah, thank you. Okay.
I have a doubt.
Yeah.
First thing is like here data type is integer 64 because the array has the numbers maybe. So can we mix the data type in a series?
as I said, if you mix the data type, it will cast all of them to the higher data type. For example, let me see. Let me say x1 is equal to np array, and let's say 0, 2.3, 4, 5, 4.7. Okay, something like this. Now, if you see what is x1, it is an array. But if you see what is the type of this, it is all float 64.
Yeah, now if we use x1 as an argument for the series, then how it will be?
Okay, sure, let's try it out. So series 2 is equal to pd dot series x1. So you see, it has cast all of them to the higher type.
Okay. And second thing, how to add the columns. Now we are playing with one column.
Yeah, no, that you're running ahead. That we're going to talk about soon. We'll talk about data frames.
Okay. And third question is like, what is the good example of the use of series?
Again,
where we actually use the series.
Series is not really that useful, but this is a good way of starting off when we start talking to data frames. Data frames is when it gets complicated, because then you have several columns. So before that, I'll just say, does anyone have any question about series? Because now next we'll go to data frames, and then we will start talking about multi-columns. So anyway, since there is not much, I will just talk about one thing, this index. All right. The question you might ask is, does this index always have to be 0, 1, 2, 3, right? The question to that is, no, it does not. So like, for example, you can access the index using this method, right? Series 1 index. And also for this series 2. So any series, you can access the index. Now, the question you might ask is, what if I want to give something else? What if this is not 0, 1, 2, 3, but this is the year, right? So this is, let's say, 2016, 2017, 2018, 2019. This is, let's say, sales numbers. Okay. The question is, yes, you can do. So for example, let's say I want to change it. I can change it. So I can say 2016, 2017, 2018, 2019. Now let me check out series 2. And you see the index has changed. The index can be anything. You can define the index as any value you want. Now here I'll stop again. Does anyone have any doubt? No doubt. So then I'll just do one other thing. The index can be not just integers, but the index can also be letters, alphabets, anything. However, you can even have date time objects. So for example, let me say series 1. Okay, series 1 is this. I could make series 1 dot index is equal to A, B, C, D, E. And now you see the index has changed. All right. So basically, the series can be said to be similar to, let's say, a list or an array. But in a list or an array, you can only access the elements by the index. Here, you can also access it by the index, that is the actual index value, or you can access it by the position. Right? So here again, I'll stop for a minute. Does anyone have any doubt?
Instead of
Specifying
typing, yeah, go on, sir.
No, go ahead, go ahead.
Yeah. Instead of typing the indexes in, if it is a character form, then instead of typing each and every indexes, is there any way that we can start say start from A and end till H or something like that?
Oh yeah, you can write actually, like for example, you can access it as an ASCII index and create. So that is also there. Like for example, if you want to do like series index, I can always write, let's say A, B, C, D, E. You can do this split. This is an easier method, right? And this will give you the same thing. Right? So there are several methods. All you have to do is you have to specify some kind of object which is ordered and has the same number of elements as the actual element. For example, supposing I say, now it gives an error. You see what I did? I removed, see there are 5 elements in the series, right? But I'm specifying only 4 in the index. Now it is complaining. Why? Because it's saying that you are mismatching your index with your data. Right? So as long as they are matched, the data in the index, you can do anything you want.
Okay. Like we have in Excel, once we have reached Z, then it starts from AA, then AB, then AC. So if we don't have any count of the elements, then how to achieve this?
Oh no! See, the way it is like this here in what do you call it? In Pandas, typically speaking, your rows will be something like, for example, when we start looking at real world data, you will see that the rows, this index, will typically be certain types of things. For example, they will be employee IDs, right? That could be one, or it could be the date. For example, let's say it is sales data. Let's say you are taking all the sales data from some store like Amazon, right? So they will say that on these dates and this time, these are the sales that were made. So these will all be your indices. So you do not have to be constrained to come up with something, because see, the problem is ABCDE does not tell you much information, right? Like ABCD, like even in Excel, you have columns ABCD, A to Z, and then AA onwards. But that does not contain much information. So the problem is you have to create your own columns to make some sense out of it. Now in Pandas, you do not have to constrain yourself to this. You create your own indices, you create your own columns, you do whatever you want. It is much more easier to access data that way.
Okay. Yeah, got it. Thank you.
Any other doubt? Okay, so now that we are here, there are several things we can do with the series, but it is much more interesting to talk about data frames. So that we'll go to next. So data frames is just like an Excel sheet, right? So we have several columns and several rows. Now, to create a data frame, what we have to do is we have to use the data frame method, right? This, like before we use series, we use, where is it here? Series. We use series that creates a series object. Now we can create a data frame. All right. Now data frame, let's go and look at the help. The help is very similar. Data, the first argument is data. Then comes index. All right. And you see something very interesting here, union collection. We'll talk about that soon. And then comes columns. In a series, there was only index. Now you can also specify columns. So how will you do so? Let's take, for example, the simple case above. Let's not complicate. Let's say x1, right? This is perfectly legal. You can have, like you can have an Excel sheet with just one column. You can have a Pandas data frame with one column. So for example, this is okay. All right. So you see what has happened here. Just like it did with series, it has created, because we did not specify an index, right? Let's look at the help again. Remember, there is index. Here, we are specifying the data, right? So if we make it explicit like this, it means x1 is our data. Now you see, we are saying that because we didn't specify an index, Pandas is generating indices automatically, all right? 0, 1, 2, 3, 4, 0, 1, 2, 3. Now, other than that, before in a series, you didn't have a column name. Now you see there is a column name. Why? Because in Pandas data frame, it is assumed that you have multiple columns, right? So it is, again, we did not specify what is a column name. So you look at the help here. There is index and there is columns, and we'll start creating that soon. If you don't create the columns, or rather you don't say what the columns are, it will just give a default column number 0, 1, 2, 3 onwards. Okay. So at this point of time, I'll stop for a minute. Does anyone have any doubt?
Yeah, so the index does not come with a column name by default, is it?
No, that's the thing. The default is always integers in Pandas, because it is basically Pandas under the hood is NumPy arrays, right? So because it's NumPy arrays, indices always start at 0 and they're integers which continue.
All right.
Any other doubt?
Now, this visual representation is characteristics of pandas, or like say when you see the output of let's say 28, you don't have the gray white differentiation. So this is specific to the package or something
This
else.
is actually something with Jupyter also. Basically, Jupyter, when you check any data frame, it automatically finds out what is the type of object it is, and it will give you, see these effects, right, that you hover and this is there with Jupyter because it's a web browser.
Okay, got it.
Okay, so now let's make things a little more interesting, right? Let's create a multi-array. Let's create a multi-dimensional array. Let me say x3 is equal to np arrange, and let's say 4 into 3. All right. So let's create 4 into 3. So let's say 12, and then let's reshape this as 4, 3. So what I'm saying is I'm creating an array starting from 0 to 12, and I'm just reshaping it. I'm giving it four rows and 3 columns. Okay. So now let's cast this as a data frame. X3. So let's see what we get. You see what's happening? It has basically taken this array and almost made it look like an Excel sheet. So we have rows starting 0, 1, 2, 3, and we have column 0, 1, 2. The reason? Because we did not specify index or column. Okay. So here I'll stop for a minute. Does anyone have any doubt? Okay, so let's go to the next thing. How do we change the index and the column? So we saw it in the previous one also, that we can just say index is equal to, and we can do the usual method again, a, b, c, d dot split. Okay, the reason is because we have 4, right? And because we have 4, we can name it as a, b, c, d, and we can just split it. So if we do this, what do we get? We have now changed our indices. We made it ABCD. All right. Now, can we do this with columns? The answer is yes, we can. So for example, if you want to find out what is the existing columns, you just have to say df.columns, df2.columns, right? And this says df2.column is a range from 0 to 3, which is what it is, 0, 1, 2, and so forth. And exactly the way we did with index, we can do with columns as well. So here I can say x, y, z dot split. And you see, we have now got a data frame with the numbers. Here we have changed the indexes and we have changed the columns as well. So here I'll stop for a minute. Does anyone have any doubt?
Yeah. So is it like each series is a single column sheet we can consider it as, and a data frame is like a multi combination of a series?
Exactly. Yeah.
Okay. Okay. So series can be always a single column. It can't be a multi-column.
Yeah. Series is always one column.
Okay.
Series is basically, you can look at a series as similar to a single dimensional NumPy array where the indices can optionally be other than integers. So you can give your own custom indices. You can think about it that way.
Okay. Okay. And if I have a series and I want to plot that in a data frame, but not as according to rows, but as according to columns. So for example, I have a series x1 which has 1, 2, 3, 4 elements. I want to map those with respect to columns, not with respect to indices. So how can we do that?
Yeah, we can do that. So for example, let's say, for example, like you said, we have, let's call this A1 is equal to, let's say 1, 2, 3. And let's say A2 is equal to 4, 5, 6. Okay. So now you want to name this as A1 should have these values, A2 should have these values, right?
Yeah, so A1 will be one column.
Mm-hmm. So now what you can
Sorry,
do,
one row, not a column. Sorry. Yeah, if
A1 will be a row.
yeah, so if we do it the normal way, A1 will be a one row, right? So A1 will be a one column, but I want to plot this with the column, not the row.
Okay. So it is like this. You can specify data, but now if you want to change it, then the only thing I would say, if you want to change it in anyhow you want, then what I will say is try to create a NumPy array and then pass it to as a data. Because there are different ways to do it. But then if you want to change everything now and then, what I would say simplest way, create it as one NumPy array. So for example, you can just say like, A is equal to np.array A1. I don't know if this will work. Let me see. A1, comma A2. Let me just see if this works. Okay. So you see, this created the same data as a NumPy array.
Mm-hmm.
Now you can create pd.dataframe with A, and you can directly specify index is equal to A1 A2 dot split. So you can specify the index at the time of creation itself. So if I say this is what I get.
Okay. So here we are plotting like A1 as one column, A2 as another column.
A1 is one column, A1 is a row. Remember, we have specified it as indices.
Yeah. So we specified that, but if I want to use that not as a rows but as a column, then how we can do?
Oh, then I guess you can change your array. So for example.
So okay, so we need to change the array. We cannot play with the data frame function.
You can play with the data frame also. So for example, there is df dot. Oh no, sorry, df3 dot. There is df.transpose. So there is this one where it will just flip the rows and columns.
Okay.
So you can do this.
Okay. So we have a functions which we use for the Excel sheet.
Oh yeah. Now, as I say, soon we will get started, but you can do very complicated things with Pandas, just like you did with Excel.
Okay.
Yeah, but here the indices are also changed when we do transpose.
Oh yeah, I mean indices will. I mean, see, it's like this. You decide how you want it. For example, how you want to name your rows, how you want to name your columns, right? And then decide how your data is. Basically, you have to decide how you want to call your data.
So maybe we can create a matrix first, then do a transpose operation to a matrix, and then convert it to a data.
Yeah, that is always the recommended way. First, express your data in some form, either output it, and I'll soon show you how to do that. You can also have your data in an Excel sheet and read it from there. That is also there. We'll see that very soon in the next few lectures, not right now. So now that we've reached here, before we end this lecture, I just want to talk about a couple of things. That is, how do you extract elements from this data frame? So for that, let's take this data frame. There are two ways to do it. The first is you use the square bracket method. When you use the square bracket method, whatever you're specifying here, Pandas will look for the equivalent object. So for example, if I say A1, you have to put it in string because A1 is a string, right? If I say DF3, oh no, sorry, you can't do this because actually I should, let me call this DF4 and then call this DF4. Let me see what DF4 is first. DF4 and then say DF4 A1. DF4 A1. So you see what has happened. When you say DF4 A1, Pandas will look for the column with number A1, with value A1. And now you see what it has given. It has given this column, but the output is a series, right? And you can check it out. See, if I take this and I say type, it's a series. So if you extract any one column from a data frame, you get a series. Okay, so here I'll stop. Does anyone have any doubt?
What if there is a conflict between, if there is a if we are naming one row and one column as the same number,
Okay.
same indices, then if there's a conflict?
So the first thing you need to know is that when you use the square bracket notation, it will only pick out columns. So for example, if I say DF4 and I say 0, okay, 0 is here, it gives you an error because it says it can't find error. Even if I put it in a string, it will not be able to find it. Why? Because it is looking for the 0 in columns. So they cannot be a conflict. So the square bracket notation is only for extracting columns, not for rows. Does that answer your question?
Yeah.
So now the question is, next one, how do we extract the rows? The way to extract rows is, there are two methods. The simplest method is what is called ILock. ILock means integer location, right? Now here you only specify the integer value of your row, right? Only, and this gives you the row correspond with the two columns. You see A1, A2, and with this row number. It's very important to understand this has to be an integer. So for example, let me say df4 dot index is equal to, let's say, x, y, and z dot split. All right. So now this is my df4. I cannot say df4 ILock x. This is not acceptable, right? Because ILock always expects an integer. You have to specify an integer only, right? Now, the question you might ask is, what if you want to access it by this value, right? Before that, I'll just stop for a minute. Does anyone have any doubts so far? I'm actually running out of time, so I'll wind up this lecture soon. Okay, so let me go and tell you, what if you want to extract this value by the index value. For that, there is something called lock, right? Now, lock means location. Locate an element or elements in a data frame. So for example, now lock has several ways in which you can use it, right? If you specify only one argument, right, that is the index. So for example, I can say y, and it gives me the y value. So you see it is the y value, a1, a2, 2, 5. And if you actually note, this is a series. So why? Because we are extracting one. If you extract one row or one column, you always get a series, right? Now, supposing I want to extract this number 6, right? How will I do so? Again, you can use lock, but now you can use 2 arguments. What I have to do, I have to say z, and I say a2. Okay. Oh, sorry, it is df4. df4. So this is just like the way we used with NumPy arrays. You can specify a row and you can specify a column. Okay. So here I'll stop. Does anyone have any doubt? No doubt. So now I'll just talk about one last thing before we go. If you want to create a new column, the way to create it is you specify A3. Let's see. Now, if I only specify A3, sorry, this is df4. If I specify only A3, it will give me an error. Why? Because A3 is not found. But if I say A3, all right, and I give it a value, right? Let's say, for example, I give it a value of 7 colon 9. Oh yeah, sorry, this has to be the same number, so it is 7, 9, 10. You will see that a new column has been added. So this is how you can add columns to your data frame. All right, so we are almost out of time with this session. I'll just stop now and say, does anyone have any doubts about what I talked about?
So subset of any data frame has to be a series.
Yeah, no, here again, you need to understand is if you extract one row or one column, supposing I extract, now you can extract multiple. So for example, if you extract just A1, you get a series, right? But if I say, A1 and then comma A2, right? And you can do this. Remember here, it's important to note the double square brackets. There is a square bracket outside and there is a square bracket inside, because the inside is a list. You are passing a list of columns. And now if you do this, you get a subset of the data frame, which is another data frame.
Okay.
Okay, does anyone have any more doubts?
Yeah, following this theme, suppose I have, let's say, about 20 columns in my data frame and I want to reject after the 10th columns. I only want the first 10 columns. So without listing out all the columns, how do I do that?
I didn't get it. You want to reject after you want to only take the first 10 columns.
Yeah, first 10 columns without listing out all the columns.
Yeah, you can just, but I suppose you will need to have some kind of logic, but